My name is Yvette Fuentes, and I'm a professor of physics at the Quantum Light and Matter group here at the University of Southampton. So my project is about using quantum systems to measure gravitational fields. So when one thinks about gravity, the first thing that comes to mind is Newton's famous apple falling from the tree. And you could actually use the apple to measure gravity by measuring the time of fall and of flight. Now there's much more sophisticated ways of doing the same thing using atoms. So you could, instead of an apple, use an atom and measuring with lasers, so you could measure very precisely the local gravitational field. Now, if you throw in quantum mechanics, you can do even better. What you could do is take the atoms to follow at the same time two different trajectories, and then they interfere back, and that would give you even a more precise measurement of gravity. This idea, which we call spatial interferometry, is 90 years old. The theoretical idea is that old. Now, my team and I have proven mathematically a new method to measuring gravitational fields as precise as atom interferometry, but the new method would allow you to miniaturize detectors. This is important because if you use time of flight, you need big detectors to get good precisions. However, with our new method, you could get the same precisions but miniaturize the system. It's important to miniaturize gravimeters because of their applications. So let me give you an example. The City of London doesn't know where the pipework is, and they spend millions of pounds making holes trying to find the pipework. So having a very precise device that can measure gravity would allow one to find the pipes much faster and easier and save a lot of money. Now, current gravimeters are around a meter square, so you can imagine how uncomfortable and expensive it might be to move something that big in a survey. You can think about the analog of computers. So back in the time, computers were huge and we even needed a building to host them. And now the technology has developed that much that we can now have a very powerful computer in our hand, in our phones. So now if you think about quantum sensors, at the moment they're still relatively big, and this new idea that we have patented is going to be one of the first steps in order to be able to miniaturize quantum sensors. What we have shown mathematically that we can do with very good results is to trap the atoms in a potential. And instead of using the interferometry in space, we use interferometry in time. And this allows to miniaturize the gravimeter. So this is a game changer because we will be able to have a very sensitive, accurate quantum gravimeter as in atom interferometry, but not having the constraints in size, but be able to miniaturize it, make it portable, make it friendlier, easier to use, cheaper, and not only use it for commercial applications, but also to answer questions in fundamental physics. The long-term vision of my project is to be able to have a quantum gravimeter in my phone. And this would not only have commercial applications in finding resources or voids underground, but it would also be able to be used scientifically to measure high-frequency gravitational waves and searches for dark matter. The sectors that are likely to benefit with this project would be, for example, civil engineering, because it allows us to find structures and voids under Earth. And this would also have interesting applications in archaeology, earth sciences, anything that involves finding structures and voids under Earth. Another very important one would be finding resources. For example, finding water, finding oil, gas as well. Any sort of resource would be one of the sectors that would benefit. I have already been engaging with companies that are using classical gravimeters, and they approached us because their gravimeters are quite big and bulky, so they're interested in the fact that the technology promised to be able to miniaturize the technology. And at the moment, those companies, for example, are looking for oil and gas, but the company is now moving towards searching for water and other applications that are more compatible with green technologies. So to take my project forward, what we're looking for is funding to build an experiment and show that the technique works in a prototype. We have proven that the technique is predicted to work mathematically, but we do need to build the experiment and show that in the laboratory. So if you find this idea interesting and you want to know more about it, please do get in touch.